Today we're going to look at Ohm's law. The relationship of current to potential difference and resistance is given by Ohm's law, which in equation form is V equals IR. You should have a copy of a table that looks really similar to this. It just doesn't have electrical power on the bottom. Affix it into your composition book and let's fill it out as we go through the next few slides. First, let's talk about electric current. Make sure you're writing each of these things in the appropriate place on the table. Electric current is the flow of an electrical charge through an object or medium. It is denoted with the letter I, and it is measured in amperes, which can be abbreviated amps, and the symbol is a capital A. Electric current is measured with an ammeter. Make sure you have all of this information in the appropriate boxes on the table. The next row on the table deals with voltage. Voltage is the difference in electric potential between 2 points. We use the letter V to denote voltage. It is measured in volts, and it is measured with a voltmeter. Next we have resistance. Resistance is a measurement of how an object opposes the flow of electric current through it. The picture shows a typical resistor. Resistance is denoted with a capital R. It is measured in ohms, which can be abbreviated with the Greek letter capital omega, measured indirectly with a multimeter. Previously, we've talked about the two types of circuits. They are series and parallel. We are going to focus on these a little more today. We're going to start with series. You should have a graphic organizer for series circuits and a second one for parallel circuits. Fold each of these graphic organizers in half. On the outside of the series circuit graphic organizer, write this description. Electricity has only one path on which to travel. Now let's work on the inside of the graphic organizer. Open it up and let's fill it out together. Series circuits contain components connected along a single path, so the same current flows through each component, as shown in the diagram. Resistor R1, R2, and R3 are all connected in a series along the circuit. This definition and this diagram are already on your graphic organizer. We can use this definition to help us determine the current, the equivalent resistance, and the voltage for each component in the circuit. First, we'll start with current. The definition says the same current flows through each component. That means the current through R1, R2, R3, and the voltage source are all the same, as shown by this equation. The total current is equal to the current across resistor 1, which is equal to the current across resistor 2, which equals the current across resistor 3. The equivalent resistance in a series circuit is simply found by adding up the resistance of each individual resistor to give the total or equivalent resistance. In a series circuit, voltage can be calculated using Ohm's law, which is V equals IR. Or you can use the relationship that states that the total voltage is equal to the sum of the voltages across each individual component. Now for the parallel circuits graphic organizer. Write this description on the outside of it. Electricity has more than one path on which to travel. Now let's work on the inside of the graphic organizer. In a parallel circuit, each component is placed in its own separate branch, or parallel to each other, as shown in this diagram, such that the voltage across each branch is equal. The definition of parallel circuit tells us that the voltage across each branch is equal, as shown by this expression. Equivalent resistance in a parallel circuit is calculated with this expression. Current in a parallel circuit is calculated using Ohm's law, or it can be calculated using this expression. The total current is equal to the current across each individual resistor added together. Now glue these two graphic organizers into your composition book.